Hey everyone, Greg here. How are you today? Very beautiful, warm Friday in Oregon, and feels good to see that sun. Well, I wanted to talk about three things, and the first is there was a couple minor problems with the correlation, and let me try and describe what happened. So let's start out with the correlation, and I'm giving you some feedback now. So let's say I put in bivariate data pairs, and so you can't correlate categorical variables, gender with the length of your pinky or something. They both have to be continuous variables, so you could correlate height with income if you wanted, okay? Now, I got some data here, and so take a look at the two pairs. Take a look at the data I put in variable 1 and variable 2. So I'm going to correlate that. Okay? I'm going to correlate that. So what I do is I select analyze, then I select correlate, and then I select bivariate, and I put both the variables in the box and I click OK. Now notice there's two numbers that come up, and this is what you have to be clear on. Let me do it again. My fingers are slipping here. There we go. Okay, now you'll see right here, you'll see the number 0.523. You'll see the number 0.523 in the output. All right, that's the correlation coefficient. That is your R. Okay? And the second one is the p-value. It doesn't say p-value, but it says significance, which means the same thing. Okay? And there's a little bit of confusion. The correlation coefficient is a measure of the degree to which the variables are linear. And in one of the assignments it said something about the probability that something affected something, but that's not correct. It's simply a measure of the linearity of the data pairs. It has, okay, so 1 is a perfect correlation, y equals mx plus b, a straight line, and 0 is no correlation whatsoever. And your null hypothesis, of course, is always that there's no correlation between two variables. Now that second number, which was called significance of two-tailed, 0.287, that's actually a p-value. And since that p-value was not smaller than 0.05, that's what's called a not significant correlation, which means that those variables might have correlated to some degree, but they wouldn't have correlated very well in a larger population. So you can reject the null hypothesis, or you can't reject the null hypothesis that there's no correlation in the population. Now, one of the things people don't understand is the R value is not the slope of any line. Okay? The R value is the degree of linearity, and so you can have an infinite number of correlations for every regression equation, and you can have an infinite number of regression equations for every correlation value. Okay, so we need to clear that up on correlation. Now, on regression, the assignment on regression asks you to put in the data pairs and then to make the reports. And you can do that, and APA requires you to put all those numbers in there, but a lot of them are pretty hard to understand. So I want to make clear what a regression equation actually is. A regression equation, let's say I have these pairs of points, okay? So I've got my data right there, and the first thing I did was I computed the R, the correlation coefficient, and then I computed the p-value. So those were the data pairs that I just put in SPSS. Now, when I select compute the regression equation, I get something totally different. You'll see two numbers in there. You'll see at the bottom, you'll see the B, which is 4.952, and then you'll see a number below it, which is 3.71. Now what they're not explaining is that those two numbers are the slope and the y-intercept of the straight line that is the line of best fit. That is the one that minimizes the distance between the points in the line. So a regression equation is used to make predictions of a y given an x. So if you have a regression equation and you build a model of amount of minutes studying versus GPA, you can input a number of minutes studying and you can predict a GPA. A correlation doesn't make any prediction, it just looks at the degree of linearity of the relationship. So remember back from high school, y equals mx plus b, y equals slope x plus the y-intercept. That's what a regression equation builds for you, as a prediction tool. And there's not too many educational dissertations that use regression equations, and there are some, and you can use them, but it's a prediction tool. Okay, so be clear when you report all that stuff for your regression assignment. A lot of it's pretty hard to understand. If you're ever going to actually use regression, you're going to have to report the slope and the y-intercept so that somebody else reading that research could build their own model, could use your model to make predictions of the independent variable, or the dependent variable based on the independent variable. So we'll finish up the regression equation, or the regression assignment, and then we'll be through with that. But spend a little time on that. Regression and correlation are not the same thing. Okay? Alright, so if the assignments come in and they have some problems, I'll try and explain them and ask you to fix them. Okay, now, moving on to next week. This is the big one. So we have to complete our final project, and we have to submit it to TaskStream. So I've had a couple people already do this. I've set up a template in Google Docs as to what a very sound Chapter 2 and Chapter 3 looks like. Now, I haven't put much in it, but in the coming days I will start to add more to it, so you'll know what a good Chapter 2 and Chapter 3 of a quantitative dissertation look like. The best thing to do is to look at the 4 examples, the research papers that I sent you. Chapter 2 is the methodology section. That's where you say, here's the participants in the study. Here's exactly what I'm going to do. This is where you state your research question. I'm looking to see if there's a difference in 8th grade test scores between 8th graders in Kansas and 8th graders in Nevada. And so each research question has to be accompanied by a null hypothesis. It has to be a 1-to-1 ratio. So then your null hypothesis would be there's no statistically significant difference between the mean score on the 8th grade math exam between the students in Kansas and Utah. And then that's what you do in Chapter 2, is you explain exactly what variables you're comparing, and it has to be crystal clear to the reader. Chapter 3 is where you produce the results of your t-tests or your ANOVA or your correlation. And you have to put your results in the tables correctly, and then you have to make your APA statement as to your conclusion. So for instance, if your p-value was above 0.5, you'd make a statement, there was no significant difference between the 8th graders, and then you write the APA formatted T degrees of freedom, P whatever. But the best way to do this is to look at examples, and I'll share the document with you and you share yours, and as we go through the week we'll start to build out this Chapter 2 and 3. And you can use simulated data, but the calculations have to be correct. So a little more on that. We're running up against 10 minutes here. And anyway, it's important that we work very closely together this week on Chapter 2 and 3 so we can submit it. So I've talked to 2 people already. I'd like to talk to everybody before we begin. So everybody have just a wonderful weekend, and I'm available to you for anything you need. Thank you. Okay, bye.